Hello everyone. In this video, we will be discussing circuit breaker pattern. In a distributed microservices architecture, circuit breaker pattern protects from cascading failures and enhances systems resiliency and fault tolerance. Lot of things in one sentence itself. Let's break it down first. So first of all, circuit breaker pattern comes in microservice architecture, where we have lot of services deployed and they are having a communication to build the whole system. Circuit breaker is a pattern that is there to protect from cascading failures. What is meant by cascading? So let's say we have three components A, B, C. And let's say C failed. And due to C failed, let's say B started failing and then A started failing. This is known as cascading. Take an example. On a road, three cars were driving: car A, car B, car C. Car C got into some accident or broke down. Car B hit C, due to which car B also broke down. And then car A, which was just coming behind car B, also hit car B, and car A also broke down. So, since car C broke down, eventually car B and then car A also broke down. And this is known as cascading failure. So, a circuit breaker pattern essentially protects us from cascading failures in a microservice architecture. So, what is the result of this protection? We get better resiliency and fault tolerance. Now, let us understand these two terms first so that we can better appreciate the circuit breaker pattern and its importance. So, the first term is resiliency, the ability of a system to maintain normal operations even when components fail. So let's say there were three servers A, B, and C, and there was a load balancer. When someone was putting a request to post on Instagram, their request was hitting a load balancer and the traffic was being distributed to A, B, and C servers when multiple requests were coming. Let's say A went down. Should the end users notice this? The answer is no. Their operations should keep continuing functioning regularly, right? So that's why B and C will take the load. So since A is now out of picture, only B and C will handle the traffic. But to end user, no change will be noticed. And this is the definition of a resiliency: to maintain normal operation even when the components fail. So in this case, A failed, right? A had failed. Even then, the normal operation of posting on Instagram kept continuing. To end users, there was no impact. So this is called as resilient system, also known as resiliency in a property sense. The second term is fault tolerance. As the name suggests, it is the ability to tolerate fault. The ability of a system to recover quickly and smoothly from failures. Let's take an example. There were two databases. One was the main database and one was the secondary database or the replica database. This replica database was having some replication lag from the main database, but it was keeping up with the replication lag. Now suppose main database broke down or there was some disruption. Then replica database will be promoted to main database, right? It will start handling the writes. And it will recover from some kind of a backup. Since main database is lost now, we still have generally backups in production systems. These backups will be used to recover the data that was lost, and replica database will catch up and become the main database. Where failures happened, but the system was able to recover very quickly and smoothly. So resiliency is when components fail. Similarly, fault tolerance is also when components fail. There is some failure in the system. But the resiliency is the ability of a system to maintain normal operations even when components fail. To end user, there is no impact. Fault tolerance is the ability of a system to recover quickly and smoothly, even though there might be some kind of disruption for a very brief moment. But the system will recover automatically, quickly, and smoothly. No human intervention should ideally be needed to call a system 100% fault tolerant. This concept has been borrowed from our nostalgia book NCERT, where in class 10th we have a chapter called as electricity. In that chapter, do you remember the concept of a fuse? If not, let's go there. This is taken from NCERT exemplar book. How does use of a fuse wire protect electrical appliances? So this is class 10th book, NCERT book, and this concept has been borrowed surprisingly from science. So this pattern is inspired from electric fuse that stops current flow if it exceeds a threshold. Let's quickly revise the concept we had read in our class 10th book. So this is a series circuit. Let's say in the serial pattern, there was a fuse. The fuse was closed. That means electricity was flowing. Electricity was represented as I, the flow of the electrical current. Now let's say in a given unit of time, a large amount of current flew. And due to that, the melting point of this fuse wire was reached and this wire melt down. So now the circuit is open and electricity is disconnected. Due to this, some appliances, let's say fan, bulb, AC, oven, washing machine, fridge, all were protected. Right? So this was the pattern. This was the fuse, electrical fuse, that stops the current flow when it exceeds a threshold. It does not stop the current automatically. It detects that the rate of flow of current is much higher than general scenario. The fuse wire melts and it protects by stopping the current. The same concept is a circuit breaker pattern in software. So similarly, this pattern prevents application from continuously making requests to a service that has problem or is down. So circuit breaker has three states. In the above example, there was a closed state and there was an open state. But in software engineering, a circuit breaker has three states. The closed one, which is much similar to the closed state of a fuse. So system continues to work as naturally since responses are successful. Let's come to the open. Due to some failure, the fuse used to melt. Similarly, the circuit breaker state turns open. So if responses fail, reaching a certain threshold, let's say we configured that if we encountered 5 failures in 10 seconds, that means on average, we encounter one failure in every 2 seconds, then we say that system is really bad. It is experiencing some failures and we should have reached a threshold. We have set this as the threshold. So it prevents other services from reaching the services and rather provides a fallback or default error response. Two things to understand. One is it prevents other services from reaching the service itself. So this is the first thing. And second is it provides a fallback or a default error response. Let's understand the second one first because it is very straightforward. Instead of returning the error stack trace itself to the user, for example, here let's say A and B started failing and C was not able to cope up with the load that it was getting. So instead of showing all the users with the long stack trace, the system will show that please wait for some time. Our system is experiencing some downtime. This is a graceful message. So a fallback or a default error response is shown to the user instead of showing a long stack trace, which is of no use to the user. The first point is quite interesting. It altogether prevents other services from reaching the down service itself. Why would someone want that? So let's say there were two services, A and B. A was dependent on B for some reason. Let's say A was sending some data to B and B was doing some processing and returning it back to A. Now let's say B went down, or at least it raised the threshold. Let's say 5 failures in 10 seconds. So we, since our system was having circuit breaker pattern, the communication between A and B is altogether broken. This is the crux of the first point. But how is it helping? The help is coming because B itself is experiencing issues. And if we bombard it with more requests from A continuously, the recovery of B will be very much jeopardized. And that's the reason we break these requests and stop the communication between A and B so that B is not bogged down by A's request. So until B is recovered or partially recovered, this communication is broken down for a smoother recovery of B. So when I say partially broken down, the partial term is covered in the third state, which is half open. So it is a testing phase where after some time, let's say there was a timeout set as 1 minute. So after 1 minute, A will start sending couple of requests. Let's say one request. It sends and test if B is recovered now or not. Am I getting the correct successful response? So some requests are allowed to be served. So A is sending some request to B. And if they get proper response, that means let's say successful responses, let's say 200 okay, right? Not 4xx or 5xx, right? Then circuit becomes closed again. So it turns closed. Otherwise, it again becomes open because we detect that still we are getting errors. Let's not bog down B and let B recover fast. So ensuring a smoother recovery of B, the system again becomes open. So you see, it is kind of a state diagram. So you might have read about finite state automaton. Let's try to build that automaton here. So three systems, three states, closed, open, and half open. So when system is working fine, it is in closed state. When some errors start happening, it goes to open state. After some timeout, some requests are sent and it is in half open state. Now from half open, if we get successful responses, it can go to closed or it will again go to the open state. So this is the finite state automaton for the three states. It can be modeled as a state design pattern. If you want me to make a video on state design pattern or create an LLD series, please comment in the video and I will try to make a playlist very soon. I also talked about the 4xx, 5xx HTTP codes. If you are not aware of that, please let me know in the comment section. I will make a short and sweet video on that. I also talked about replication lag. If you are not aware of that, please comment in the video section and I will try to create a video and cover this topic as well. Let's come back to the topic. Netflix Hystrix is one implementation example of circuit breaker. So if someone asks you, can you give me an example of circuit breaker? You can tell that Netflix Hystrix is one implementation example of circuit breaker pattern. So in this video, we discussed what a circuit breaker pattern is. We discussed the difference between resiliency and fault tolerance and how circuit breaker pattern ensures both. We discussed how it is inspired from electricity chapter in science. We discussed the three states of a circuit breaker, namely closed, open, and half open. And we saw that Netflix Hystrix is an example of a circuit breaker. Please like, share, and subscribe. I keep creating such videos on a regular basis. If you find any topic which is hard to understand, please comment down and I will try to cover that topic in an upcoming video. Thank you so much.